Learning Objective 1 from Section 6.4 is to recognize how influential points affect the values of the correlation coefficient and of the coefficients of the regression line. The coefficients of the regression line are the slope and the intercept in the regression equation. What effect would adding a child with a height of 26 inches and a head circumference of 16.5 inches to the scatter plot have on the correlation coefficient and the equation of the regression line? You can see in this scatter plot that height in inches is the explanatory variable, it's our horizontal variable, and the vertical variable, or the vertical axis, is for head circumference, which is the response variable. If we were to draw a line through the middle of these points, it might go something like this. If we were to add a point that has an x value of 26 and a y value of 16.5, it would fall about right here. And the regression line through those points might look something more like this. So notice that there are several changes that happened. The correlation coefficient would change because the points are now not nearly as close to that red line as they were to the blue line. So the correlation coefficient would become weaker, closer to 0. Also, you can see that the line crosses the vertical axis at a different place. So the intercept would be different. In fact, right now, that vertical axis is not where x equals 0. So if we were to shift that vertical axis clear to the left at x equals 0, you could see as you continue those lines that the intercept would actually be quite different. Also, the slope of the line is different. It is much less steep. The red line is much less steep than the blue line. And so therefore, this would decrease the correlation coefficient, make it closer to 0, and it would also change the slope and the intercept of the regression line. An example of answer B, something that would increase the correlation coefficient but not change the slope and the intercept of the regression line, would be something like this. Let me erase what I have here. And if we were to add an outlier that was somewhere up here, it's far away from the other data, but it would not change the regression line's equation. The intercept would be about the same and the slope would be about the same. But the correlation coefficient would become stronger because now I have another point that is right along that line. And so that would be an example of an outlier that would have the effect in answer B. Most outliers, because they are far away from the rest of the data, will have some effect either on the correlation coefficient or the slope or intercept of the regression line.